Good afternoon. Today we are working on math packet number 10. It is due the day we come back from Easter break. So you need to be working on this. It is not that far away. We had spring break in there, so we've had time to work on it. But I understand that we've had other things going on over spring break, so we might not have. So that's why today we're doing the video in class, and hopefully we'll have time to work on this in class. Our first page. Alexis and Beanie drove to Philadelphia for the weekend. They decided to see some of the landmarks and needed a place to park for 3.5 hours. They see two signs advertising two different parking lots and go with the cheaper total cost. How much do they pay to park? So in order to solve this, you need to figure out how much they're going to pay at Pat's parking and how much they're going to pay at Paul's parking. So you start with the first hour. And so you know that for the first hour, for this one, it's going to be $8. And for the first hour over here, it's going to be $6. And then we have to go every half hour after. So you're going to say for 1.5 hours, how much do they pay? For 2 hours, how much are they going to pay? And I would just do, hey, it's 60 cents. This is another 60 cents. And you want to go all the way up to 3.5 hours. And then you add it all together. Do the same thing for Paul's parking. Find which one is the cheapest, and that is your answer. But you're going to want to go up by those half hours all the way until you get to 3.5. Add them all up and to get your total. This page isn't as hard. The next page is a little bit trickier. All right, a train leaves the station at 1 p.m. It travels at an average rate of 60 miles per hour. A high-speed train leaves the same station an hour later. It travels at an average rate of 96 miles per hour. The second train follows the same route as the first train on a track that's parallel to it. So it's not coming up behind it and going to crash into it. The tracks run parallel. In how many hours will the second train catch up with the first train? So I'm going to tell you this much. It's not going to be an even hour. Okay? You're going to have minutes tacked on there. So the way that I solved this was I figured out how my train was leaving, the first train. So he leaves, and then we have 1 hour. I did 2 hours, 3 hours. So at 1 hour, he's gone 60 miles because he's going 60 miles per hour. So after 1 hour, he goes 60. So after 2 hours, how far will he have gone?
120.
120. After 3 hours?
180.
180. So then when we look at our second train, when that first train has gone 60, that's when he leaves. So then his first hour, how far has he gone? 96 miles. Has he caught him yet? Nope, because he's got 120. He's only got 96. So in his second hour, how far has he gone? 192. And he's got 180. So he has passed him up. We want to know the time that he meets him, not that he's passed him. We want to know what time is it that he actually catches up to him. So we're going to need to know the minutes, and you're going to have to use your knowledge of factors and what each number is divisible by. If this one's going 60 miles an hour, this one's going 96. What can I divide both of those numbers by? Those common factors that I can divide it by. So I can say, maybe if he's going 10 minutes over, or 20 minutes, or 30, or 40, you're going to figure that out. So you're gonna look to see how long does it take for this train. So we don't want the hour that's up here, we want the hour that's here. How long does it take this train to catch up? So it's not going to be 2 hours, because he's way past him at 2 hours. So you have to figure out those common factors, divide it down, and then go by smaller increments. So instead of jumping by an hour each time, you're gonna jump by so many minutes. So figure out which of those minutes is the right way to jump. It took me a couple of tries to find the right one where they both are at the exact same distance. So you have to have the same number for both trains. That make sense? Yeah? All right, our next page is our 5-card challenge. Challenge yourself to start finding the 5-card challenge. Use all 5 cards to equal 2. When you get to Mr. Schultz next year, he might expect you to have algebra, not might, he will. Algebra and geometry students must have at least one correct 5-card challenge. So start challenging yourself now. How can I use all 5 cards using different ways of doing PERMDAS to equal 2? Some of us have gotten good at using all 5 of them. Some of us just do 2 or 3 cards at a time. Challenge yourself. See if you can find that 5 card, because next year you're going to have to. So start working on that now. Our next page is our pattern blocks page. So remember, we're filling in what we know. The first thing I did was I looked at this as figure 1, figure 2, figure 3, figure 4, figure 5. So you can fill in for all 5 figures. Then what do we look for? You look for patterns, right? With square roots, with squaring. See if you can find those patterns. And I'm going to point out some of those patterns that we can look for to help us. Pre-algebra, we need to go to the 9th figure. So you do not need to go past that 9th figure, but you do need to fill it all in. We should easily be able to fill in the first 5 figures. And then we have 4 that we have to find those patterns to be able to fill it in. So you might want to be on the same page as us. So right now you should be filling in. So you can see, first one is easy. There's 1 yellow and zeros of the pink, blue, and red, and then 1 total. There's only 1 block. What numbers do I put for figure number 2? Evelyn?
1, 8, 0, 0.
Don't leave me hanging.
9.
Thank you. So there's still 1 yellow. There was 1 yellow in the first figure, 1 yellow in the second figure. This time we have 8 pinks going around it. 0 blue, 0 reds. So we have 9 total. What do I put for my third figure, Audrey?
1, 8, 16, 0, and 20.
What do I put for my fourth figure, Evelyn?
1, 8, 16, 24, 49.
And my fifth figure? Audrey?
32, 8, 16, 24, 80.
So here is one mistake that was made there. Does anybody know what mistake, Evelyn? Because we have that 1 yellow in the middle. So you can't just count the outside. You also have to count inner colors that you might have. So instead of 32, it is 33. And instead of 80, it is 81. So, looking at our 5 figures, what are some patterns that we're starting to see? Evelyn? Is that a square root? Or is that a square? Squares. Evelyn says, hey, I look at those totals and I see some square numbers. Those perfect squares. Mrs. Gambino's favorite kind of numbers because we see those in patterns all the time. So 1 is what squared? 1 squared. What is 9? What is 25? What is 49? What is 81? What is my next one going to be? Because it is what kind of numbers? Odd. We're going up by those odd numbers and we're squaring them. So this is going to help us fill in our total boxes. 13 squared, 15 squared, 17 squared. So now we can fill in the totals all the way up to that 9th figure. You're just going odd numbers squared. So look for those patterns. What's another kind of pattern that you notice? Looking at our individual color groups. Emma?
They go like around one and like go every color and like around each other. Explain.
So what are we skipping by? 1, 1, 1, 1. Ooh, we're jumping up. So 1, 2, 3, 4, and then we add more. But every 4, they're the same number until we add that color on the outside. So if we look at our yellows, we have 1, 1, 1, 1. Then we have 33. How many yellows are there going to be for figure 6? 33. Because we know that there's going to be 4 of the same number. So 1, 2, 3, 4. So we can easily fill that in because we're following the pattern. Can I fill in the 9th one? Not yet, because I don't know. I followed my pattern of 4s, and now, okay, I'm to the end of it, can't fill it in quite yet. Let's look at pink. Can I fill in pink for number 6? No, because we've already done 4 8s. Can I fill in any more blues? How many?
1.
I've got 1, 2, 3, so I need 1 more at the 16th. What about my reds? 2 more of the 24s. So if I know that this is 11 squared, what is 11 squared?
121.
Can I figure out how many pinks there are? How? I know the total is 121. I need to take away the yellow, the blue, and the red, and I'm left with the pink. Then if I know this pink, I can fill in the next 4. You're just going to fill in as you go along, and you're going to be left with 1. Take your total, subtract out the ones that you know, and you're left with the one you don't know. Fill in for the next 4. So Mr. Schultz says you only have to go to the 9th. Could you easily go down to the 12th? Yeah, because we're given all of the pattern tools that we need. You could fill in the whole table. You only have to do it to the 9th. Make sense? All right. Our next one, we need to draw a net and label it. And let me tell you, this has been kind of a confusing thing for a lot of us to do. We figured out how to draw the net, but where do we put those labels? And then we have to do the pre-algebra, finding the surface area. So there's 2 big parts to this. First one is the net with the labels. I'm going to walk us through that, how to label it, So it comes easier for us. So what shape do you think I should start with? If I were to cut open this triangular prism and lay it out flat, what would that look like, Aiden? A rectangle. Because if I look at this, I see that there is a big rectangle as its base. What else do I need? Evelyn?
On the sides, you need a triangle.
I need triangles on my sides because there's triangles on each side. What else do I need? James?
And then 2 more rectangles.
2 more rectangles because I have a rectangle on this side and a rectangle on the back side. So I need 2 more rectangles. So that is my net. That's what it looks like when I open it up. I have to label it. How do I figure out where my numbers go? Labeling it means you're putting your numbers and your variables in the correct spot. So who thinks they know where some of these numbers go? Emily. The 8 is the height of our triangle. So it goes in that middle. What other measurements can we fill in? Let's give us a moment. Anybody else have an idea of where some numbers should go? Ben?
Like the width of the rectangle.
Uh-huh.
That's a 10.
So the 10 is right here. Where would that relate to my net?
On the side.
Like here?
Yeah.
Yeah. So I could do a 10 there and a 10 on the other side. So same thing up here. Is there any other places I'm going to put that 10? Tatum?
On the triangle.
Yeah, because if I fold this side up, this triangle has to be the exact same measurement so they meet each other perfectly. So this side is a 10, this side has to be a 10. So my sides of my triangles all need to be 10s also. What about this side of my triangle? Is that a 10? Evan?
Yeah, 12.
Yeah, that's the 12. So there's a 12 here and a 12 on this side. So be careful with that. We have some sides are 10, some are 12s. That's an easy mistake. I was quickly going through my answer key. And let me tell you, when I was going through it with the last class, because they had the same page, I went, oh, I put a 10 there instead of a 12. So be careful. These 2 are 10s, but this one is a 12. So now we have one more label that we need to put on. What label do we have to put on? Emily?
The X.
The X, and where do I put the X?
On the length.
Yeah, that long side here. So each of these are X's. All right, so now I'm done with this part. I have to do this part, finding the volume.
Wait, do you need to write?
Or sorry, finding the surface area. So you need to have this whole net drawn out and labeled correctly. And now we're moving on to the second part. So we know our volume is 960. We need to find the surface area. What do I need to do with that volume?
Divide it by X. Or not, if you add all the numbers up and divide it by that.
Close, not adding. We're going to use it to find this missing variable,
Yeah.
right?
Okay.
So our volume formula is 1/2 the length times the width times the height. So what we're gonna do is we're gonna plug in what we know, and we're gonna solve for our unknown. So our volume, we know is 960. That equals 1/2 of our length. Do we know our length? No, so I'm gonna put an L. Do we know our width? Circle. We're going off of the triangular prism, not our neck. So our length, we don't know. Our width is the 12, and our height is the 8. So now we have to do those opposite operations to solve for the L. Get L by itself. So either multiply or divide to get the L by itself. Okay, so those opposite operations come in handy. Once you solve for that, you'll know what your X is to fill in. And then we need to find the area, because to find the surface area, you need to find the area of every shape. So to find the area of the rectangle, we know is length times width. So you're gonna do length times the width, length times the width, length times the width. So you're gonna have 3 numbers for area for each of our rectangles. Are they all gonna be the same? No, because we have a 12 here, but 10's here and here. Then we need to find the area of our 2 triangles. Anybody know what the area of a triangle is? What that formula is? James?
Isn't it 1/2 times L times W?
Close. Not L and W. We call it the base and the height. Because length and width are all on the outside. The base is on the bottom. And the height goes up the middle like that. So 1/2 the base times the height. So base, height, divided by 2. So you're gonna find that for both triangles. Is that gonna be the same number in each of the triangles? The base. So your base and your height. So the base is the bottom of the triangle, the height goes up. They're gonna be the same because the measurements are the same for both of the triangles. Once you find all 5 areas, you add them up together, and that is your answer. Okay. Let's move on to our next page.
Oh no.
All right, he gave us some numbers already, like he's done on other formula pages. I am going to write in the formulas for us so we can make sure we know all of the formulas. Keep in mind that pre-algebra has to do 3 of them. You can challenge yourself to do more. So, formula for a rectangular prism is length times width times height. The formula for the volume of a cube, side cubed, or that's the same thing as length times width times height. Why do you think I put side cubed instead of length times width times height? Because all the sides are equal, because it's a cube. So if I say side cubed, it's going to help me remember that all 3 numbers have to be the same. 3 times 3 times 3 is 27, right? So you're going to see what number, if you multiply it by itself 3 times, you're going to get that volume. Triangular prism, we just did this one. 1/2 the length times the width times the height. For our pyramid, it's length times width times height divided by 3. Our cylinder is pi r squared times the height. Our cone is pi r squared times the height divided by 3. And our sphere is 4/3 times pi r cubed. So those are the formulas that we need. You need to do at least 3 of them. You can do more to challenge yourself. Some of us had chosen geometry to be working on this trimester. Math testing is coming up in a few weeks. I don't know the exact dates, but usually it's towards the end of April. So that's starting to come up. Be working with these formulas. Get familiar with them. All right, let's look at our next page. All right, find the area of the entire figure and the shaded region. So the entire figure is a rectangle. So the area of a rectangle we know is our length times the width. So find your length times your width, and you're going to put that here. You're going to put your math that you do, what you're multiplying together right there. Is there an easy way to figure out our shaded right off the bat? Is there a formula I can use to find the shaded? There's not. It's a goofy shape. There's a triangle here, but I don't know what this measurement is. There's a quadrilateral over here. I don't know how to find that. It's not like a rectangle. It's not an easy shape. So what do I do? How do I find my shaded area, James?
Find the area of the triangle and then minus that.
Oh, I can find the area of the white shape. That's a triangle. And I can subtract the white away from the full figure, and I'm left with just the shaded. So the area of a triangle we just talked about was 1/2 the base times the height. So let's look at this. Here is our base, the bottom of our triangle. Do we know what that measurement is? Yeah. But if I do my height all the way up to the tip top, what is that? There's no height inside my triangle. How do I know what it is? You think you know, Michael?
I was gonna say 6.
Yeah, because look at this. Our triangle starts off down here, and it goes all the way up to here, and we know that that is a 6. So just because it's off to the side and not in the middle of our triangle, it's still the height of the triangle. It goes from the base to the tip. That is your height, straight up and down. So we're not going diagonal like that. We're going straight up and down from the base to the tip. And we know that is a 6. So you plug in your height and your base into your formula, and that's going to get you the white area. So I take my full area, I subtract out the white area, and I'm left with my shaded. Does that make sense?
Mm-hmm.
The tricky one with this triangle is the height was actually on the outside. Just know that with the triangle, it goes from the base all the way to the tip in that straight perpendicular line up. All right, let's look at our next page. All right, Fibonacci numbers. You're gonna miss. Fibonacci numbers. We've been working with these Fibonacci numbers. We're going to do something different with it today. The composition of a number describes how the number is made up, or put another way, how it's formed. The Fibonacci sequence can be used to determine how many ways a positive integer can be written as the sum of 1s and 2s. To help us, we use the table below. I'm just going to scroll up just a little bit. All right, so I'm not going to read through all of this. I'm just going to break it down for us. What we're going to do when we write the compositions using 1s and 2s for n5. So I'm going to look at my Fibonacci for 5. Let me turn to my right page. I'm going to see how many different ways I can equal 5, because my Fibonacci of 5 is 5. That's the 5th number in the Fibonacci sequence. There are plus 1. There are 8 different combinations I can use to make 5. So if I'm using 1s and 2s and I'm adding them, what do you think is the easiest first way to get to 5? Is that Priya? Yeah.
1 plus 1 plus 1.
1 plus 1 plus 1 plus 1 plus 1. That equals 5. That's one way that we can do it. But I know there's 8 ways. What's another way, Emily? 2 plus 2 plus 1. I still have 7 more ways. Aiden.
2 plus 3.
Nope. 1s and 2s. We can only use 1s and 2s. Tegan.
2 plus 1 plus 1 plus 1.
2 plus 1 plus 1 plus 1. Audrey.
I have a question.
Yes.
Are you allowed to mix up the numbers, like 1 plus 2 plus 2?
Mm-hmm.
Okay. 1 plus 2 plus 2.
So we had 2 plus 2 plus 1. You could do 1 plus 2 plus 2. What's another way? Emily.
1 plus 1 plus 1 plus 2.
1 plus 1 plus 1 plus 2. So far we have 5 ways. There are 3 more ways. Who can find another? Michael?
I just got pointed out something. The 1 plus 2 plus 2 is the same thing as 2 plus 2 plus 1.
We know that.
And somebody asked, does it have to, can we switch the order of them? And I said yes. So looking at that 2 plus 2 plus 1, is there another way of rearranging them that we haven't used yet? Priya?
2 plus 1 plus 2.
2 plus 1 plus 2.
That's right.
I have 2 more ways left. Who can find one of them? Tatum. Alexis?
I have a question.
Yep.
So with the one that goes 2 plus 1 plus 1 plus 1, did I put like the 2 in the middle?
Yes, we can rearrange them. We could say 1 plus 2 plus 1 plus 1. So what would our last one be that we haven't done yet? 1 plus 1 plus 2 plus 1. So that is 8 ways using those 1s and 2s to get to 5 for our answer. So this one you're going to do on your own. Write the compositions of 1s and 2s for n equals 6. So if F6, we need to equal 8. Sorry, we're not going to equal 8. I misspoke. So F6, there are 13 of them that are going to equal 13 ways where it equals the 6. I got confused on this one because it was 5 and 5. But we want to equal that 6. So we look at the one next to it. There are 13 ways that we can equal 6. Rearranging where we have our 1s and 2s. You need to find all 13 without repeating the same order. Put them in different orders. Find 13 of them. Okay? Only 1s and 2s. Only adding. Next page. Polynomials, make them fit into our little man over here. And our logic, like Sudoku. How many of us have done Sudoku? Okay, so you're going to use the numbers 1 to 4 in each of the boxes. Use it only one time. Going across, going up and down in the box. So using 1, 2, 3, and 4 You can't, in your columns, in your rows, in the box, you can't have the number duplicated. Make sense? All right, and I believe this is our last page. So if you are watching at home, we hope you are well. We hope to see you soon.